In this video, we're finally going to address something that we've just sort of been glossing over for a while now, and that is the notion of type parameters. Okay? So, when we talk about type parameters, we're really talking about the things inside of these angle brackets. So, anything we put here is a type parameter. Okay? So, what exactly do I mean by this? Well, before Java 5.0, let's say that let's just think about this in general. Let's say we want to create a list of integers. Okay? So let's just call it list int. Okay? So, yeah, this is great. So we write a whole data structure. We don't really know how to do that yet, but let's say that we have a data structure for integers. But then let's say, well, I want to have a data structure for doubles. Alright, you make another one. Then you want another one for strings. So, list string. Okay, you make another one. Then you make one for booleans, and you make one for doubles, and then you make one for chars. You make one for other lists, like you have a list of lists, and you make one for arrays. And well, the problem is there's accountably infinitely many types we can have. Okay, that's not entirely true. There is a limit, but making this many instances of all of them is just ridiculous. You would never be able to do that because you would just be copying and pasting the implementation and changing one thing. Well, the way Java gets around this, at least before Java 5, was to be able to just create lists like this. So you could do list ls equals new array list. Now notice that I'm forgetting those type parameters because the way this would work is that these data structures would store instances of something called object. Now, everything in Java is an object. Everything that's not a primitive is an object. So strings are objects. The integer wrapper class is an object. The double wrapper class is an object. Anything, lists are objects, array lists are objects, sets, maps, everything that is not a reference type, everything that is a reference type, anything that is not a primitive is an object. And what that means is we can just do something like ls.add. If you want to add a string, unfortunately you can't just do like the string hello, because this list only accepts objects. So what we have to do is cast this explicitly to an object. And then this will work. So this is already pretty bad, and what's worse about this is that we can store anything in this list. So we can store things, so we can create what's called a heterogeneous list. And all that means is that we have things that are not of the same type in a list. Okay? So this is already pretty bad. We don't like this approach. We don't like this, and we don't like having to specify, we don't like being able to put multiple things in the list, because that makes it hard to, then like when we're processing the list, this is where it's sort of doubly, or it's triply bad. So if we're trying to do string s equals ls.get 0, well, this isn't going to work. This isn't going to compile because, remember, this list stores objects, not strings. So we'd have to explicitly cast this from an object to a string. And this is really bad because what if this thing isn't a string? Right? What if it's an integer? Then you're going to get something called a class cast exception. And essentially all that means is that we're trying to cast, so like if we did, just for example, if we did ls.get 1 instead of 0, we would get a class cast exception because we're trying to treat an integer as a string, and we can't do that. So Java implemented something known as type parameterization, also known by its more common name as generics. So what are generics? Generics are just a way of saying that a type can operate over any other type. So for example, the list data structure and set and map and all those are all generic because they work over any type. And under the hood, the way that they work means that no matter what type we pass here, it's always going to work the same. So that gets rid of the need to have different types of lists, or a different type, like, having the list of integers versus list of strings versus list of doubles, blah, 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 blah. That gets rid of that need, which is kind of cool. But that also means that we don't have to do an explicit casting. So this means that if we say that a list is a list of strings, then when we're doing something like int x equals ls.get 0, this is now going to be a compile time error because this list says, we say that it stores a string, but we're trying to treat something as an integer, and that's not going to work. So generics are a compile time feature that try to prevent runtime errors, like those class cast exceptions. They also make it so, well, yeah, that's sort of the big thing. They get rid of the potential runtime errors of having to cast between types and things to that effect. So it makes code much, much, much nicer to write. Okay? But the thing is, we're not really going to take full advantage of generics at this point in the class, because the main reason we like generics is because we can make classes generic. We can make classes generic. So, and what I mean by this is someone designed the array list, the hash map, the hash set, and all those types of classes. Someone did that, and we're going to do that as well. In a few weeks, we're going to build a mini array list implementation that is generic from the ground up. So we're going to see what that's like. But for now, we don't know what a class is. We don't care what classes are. So we're not going to utilize generics to their fullest potential, unfortunately. What we are going to do is create static generic methods. So what do I mean by this? I mean that, let's say that we have a method that we want to operate over any type. So for example, let's say that we were writing a method to take n elements from a list. So obviously this seems like something that we would make generic, because we just want to be able to take n elements from a list of things. It shouldn't matter, like, we shouldn't have a separate method that would, like, create a list of integers, and then we might call it, like, take int, and then receive a list of integers, and then an int n. So, and then, we have to rewrite this for strings, for doubles, for everything. So that's not a bad idea. Let's not do that. Okay? Instead, what we can do is make the method generic. So how do we do that? Well, we can do static, and then we're going to put something here. We'll come back to that. So we know that we're going to return a list of some type. Again, we'll come back to that. We're going to call the method take, and it's going to receive a list of some type. We'll just call it ls, and then it's going to receive a parameter n for how many elements we want to take from the list. So it's not going to modify ls. It's just going to say, like, for example, if we have a list of 10, 20, 50, 100, and we do take 2 from this list, we're going to return the list 10, 20. Okay? If we take 4, we're going to get all of them. If we take 5, then we're just going to take everything from the list. If we take 0, then we'll get nothing. If we take 1, we'll just get 10. Okay? So instead of putting integer here, it might be nicer to do something like saying, for all types t, we're going to say that t is what type we're going to use here. This is going to be the generic, what's called type qualifier. It's also sometimes called a type quantifier, and actually I think quantifier makes more sense. So if you don't know what this upside down A means, it just means for all. It's a logic symbol. So for any or for all types T, this method operates over any type. So that's something that we'd like to say. So we've actually kind of already done the majority of this. So we're going to say that this list is of some type T, and it receives a list of type T, and it returns a list of type T. But how do we say that T is in the scope of this method? So the type T is parameterized over this method. Okay? So in addition to, like, when we call the method, the type of the list that we give to it is going to be substituted for T. Okay? So for example, if I do take and then list.of and then 10, 20, 50, 100, and then I pass 2, these T's are going to be at runtime substituted for integer. Okay, at least that's what's roughly going to happen. That's actually not quite what happens, but for all intents and purposes, you can think of it just substituting for the correct type. Okay, but we need to say what, like, where T is being declared, so to speak. The way to do that is we're going to pass T inside of angle brackets. So this thing here says that T is a generic type parameter inside of this method. And these should always come immediately after the static keyword. Again, we don't know what static means yet. We're just still typing it. So immediately after you type static, if you're writing a generic method, put the type in parameters, or inside of these brackets, these angle brackets. Okay. Additionally, you can also quantify over multiple types. Like if you want to say that, like, you're receiving a map, a generic map of values, like let's say values of type K, keys of type K to values of type V, we can do that. All you have to do is just specify both and separate them by a comma. So for example, we do something like this. And if we were returning a map, we could do KV. Okay? If you want them to be the same type, then you don't need a separate, you don't need to declare a separate type. Like you can just say, if you want the keys to be the same type, then you'll just do map KK. And then this will actually prevent you from calling the method with keys and values that are of different types. Okay? So generic methods are really powerful, and in the next video we'll actually design this method, because I mean, in actuality this is very simple, but I do just want to walk through it just to show you how to write a basic generic method.